Hello YouTube, RJ. Hey, I got the voltage calibrator controller board designed and sent off to PCB way to have them made. And I did something a little different this time. I used the Global Direct, I think it's called, shipping, the very cheapest shipping they have. It was like $7 and something cents. I thought I'd give it a try. I knew it might take quite a bit longer, so I thought, well, it'll be okay. And I got 5 boards, $5. I could have went 10 boards for $5, but the shipping went up a few dollars because of the weight, and I didn't need a bunch of boards. So five worked great. 5 boards, $5, $7 roughly. It was like $13 and some change, which I thought was pretty darn good to get a professional, 100 millimeter by 100 millimeter board made, and to get 5 of them at that. So I got that done, got it shipped from China, and believe it or not, it took 9 days, which is only a couple days longer than doing the $25 shipping or whatever, $30 shipping, whatever it is. So pretty cheap, $13 and some change. So anyway, let's take a look at them, see how they turned out. I expect, being PCB way, that they're going to be really nice. They always seem to do a good job for me, even though I'm not one of their sponsored YouTubers or anything. So let's take a look at our boards. Didn't have to do anything special, just the green, the normal green, white silk screen, standard, 1.6 boards. Looks pretty nice. Silk screen looks good. Got the Linky logo on there for the Lynx Electronics Lab. That's how it turned out. Now the big thing is going to be hopefully everything fits and I didn't make any mistakes. Odds are not in my favor on that one. You know how it is, that first board prototype. So anyway, I guess what we need to do is build one of these up and test it out and see if we think it's going to work. So let me get set up for that and I'll be back. All right, I got the board out here and maybe a little diagram where surface mount stuff goes. I'm going to put on the surface mount stuff first. I'm just going to do it by hand. I didn't do a silk screen this time. There's not that many. They're 805s. They're not that bad to do. So I'm going to just manually do this. I'll do it under the microscope, but I will catch some video for you and let you see how that looks while I'm putting them on. So once I've got that on, I'll come back. We'll see where we're at. We'll move forward, get this board built, see if this thing works. Okay, because my microscope recording doesn't do audio, I'm just doing a voiceover, but you can see what I'm doing is I'm going to one side of the surface mount capacitors and resistors and just putting a little bit of solder on the pad, a little bit of a bump, and that's going to let me place it, as you'll see in a minute. Okay, now I've got the part laid out there, my 180 ohm resistor, and what I'm going to do is I'm going to take my soldering iron, I'm going to get the tweezers and grab it, lay it on one side. I'm going to heat this and slide it into place and use the tweezers and the iron to help me steady it in place, pull the iron away, and let her stick good, making sure I've got it right where I want it. And I'm not too worried about that solder joint. I'll come back and hit it after I've got the resistor soldered on the other side. But what you'll see is you'll see me getting out another part, and I'll just keep doing this. I'll put them all on the board with the one side tacked down. And then I'll come back in a minute and I'll show you how I go do the other side. And that puts it in place. The other side I only have to do one time because I'm going to actually solder it with fresh flux off the solder. So let me tack her down in place again, and we're good there. And I'll pick back up when I'm doing the other side. Okay, now you're going to see me come in now on the other side that wasn't soldered, and I'm going to solder using fresh solder with flux. So once this side's down, I'm done. I don't have to do anything with it. But once I get all of these soldered on this side, what I do is I go back to the first side and I just touch it with a little fresh solder just to get a little flux on there, make sure I got a good connection. Now, it's going to leave a lot of flux all over the board because I use the solder I use, has quite a bit of flux in it, as you can see. But that's okay. We'll clean the board up, so it'll be marvelous when we're done. So that's how I get these surface mount parts on. I just wanted to get a little video of that to kind of show you how I do it. And so we'll pick up after I've got them all on. Okay, I've got the surface mounted resistors and capacitors mounted on the board. Board needs to be clean, but I'll do that a little bit later. Now I'm going to be putting on some additional parts. I've got one of the things I'm going to do is the Nano Everything. I'm going to put him on sockets to in case I need to pull him off and replace him for any reason. The board's not right. I need to make a new board or whatever. Just to make sure I've got myself covered. A little bit tall sockets, but it's what I had, so that's what we used. So that'll go on. We've got our little relay. I'll hold up on the relay till I clean the board. I don't want the board going in the ultrasonic cleaner. The relay, I don't want it to go in it. I'll wait till I get the board clean in the ultrasonic cleaner before I put the relay on it. I don't want it to go through that. These will be fine. See, I've got the relay here. Got the transistors to trigger it. I'll grab some diodes and put a couple 1N41, 48 diodes in there as the coal flyback diodes. And then you got quite a few of these JST connectors to put on. So it's going to be quite a little bit of soldering, but it's all through hole, easy stuff. I won't bore you with it. I'll just get it done and get the board clean, and I'll come back. And then we've got a lot of cable work to do. We've got to rig up for our off-board 24 volt to 5 volt regulator and just a whole bunch of stuff. But we'll get it all done, and it may be tomorrow, but I'll see you when I'm ready. All right, I finished the board. It's all done. It turned out pretty good. Here, you can take a look at it. With one exception, I've got a little fuse, a 2.5 amp fuse through hole goes here. And I missed it on the order. I've got a couple of them coming. So the question becomes, do I just jump that? We're hooking up a battery. This thing's got a lot of capacity. I'm a little nervous of doing that. So I think I'm going to hold up and wait for that to come in. But anyway, it's getting late. I'll wait till tomorrow to make the decision. Either I'll wait for the fuse to come in or I'll jumper it. And then we can start testing to see, did I mess up? Is everything the way it's supposed to be? And we'll go from there. You will see me in just a second, and I'll see you tomorrow or in a few days, one or the other. So, all right, I'm back next day. I've decided to go ahead and jumper that. And how I'm going to do it is I'm a little nervous to hook a battery with this kind of capacity into a circuit that's untested. So what I'm going to do is I built up a jumper power wire for my bench mode power supply where I could put limiting on the current. And so I'll limit the current, and that'll keep us safe. And so I'm going to do that for testing instead of waiting on the fuse to show up. But I'm having to get everything ready. This is the little 5 volt switch mode power supply. Takes up to the 24 volt that I'm going to be putting in from the battery. Gives me out 5 volts with very little loss. That'll keep our battery life decent. If I did it linear regulated, I'd have to get rid of a bunch of heat, be a bunch of wasted battery power. I'm wasting in heat. So this solves the problem. So anyway, what I'm doing right now, if you can see, maybe where you can focus, I'm putting connectors together, the little JST connectors. I'm having to put connectors on these. I've had to adapt this down to a smaller wire to be able to put JST XHs on it, and they'll handle plenty of current. But this thing's designed to be able to supply 5 amps, so it's got a much heavier wire. So I've converted down, soldered smaller leads on that would work in these connectors, shrink wrapped it, and now I'm just getting the ends on. I've got just the red here for the 12 volt, 24 volt input, and then I can get that hooked up, and then I've got to probably make a couple more cables maybe. I have to see what I have to come up with, and then we'll be ready to power this thing up, do a little testing. So, okay, I got those connectors put together here, and I'm tinning some wires up. You see me opening all those AliExpress bags with stuff, and I wonder if y'all realize how much I use the stuff that I do order. So here I am, just my little magnetic plate, if you remember back from quite a while back ago, for holding circuit boards and things. I use this little handy magnetic thing, little clamp thing, a lot. Like I'm tinning these wires, and man, how handy can it be to have this to help me tin these wires? I'll tell you about these wires just a second. Let me get them tinned real quick. I'm using the wire here, instead of actually jumping the fuse spot over here, right here, what I'm going to do is I'm going to solder a set of wires to it. And then what I'm going to do is I'm going to use my ammeter clipped across it so I can monitor the current it's pulling. So it'll do the same thing as a jumper, but it gives me the benefit of watching how much current's pulling. Now I can watch on the other meter, but this is just a handy way to jumper it and watch it off of one of my other meters. I'm going to run it from my uh, linear power supply on the bench, my old beast over here, and it has analog gauges you can't tell very small amounts of current with the needles. This will let me use one of my digital meters to get real accurate. So anyway, that's what I'm doing. That's why I need these little wires. So this is a very handy thing. I use it all the time. I was using it a while ago to do these wires. I just thought I'd point out that I do use all this stuff that I get from AliExpress. I'll give you reviews. I'll tell you right now, like, I like this. This is worth the money if you decide to buy one. If you go back and look through my AliExpress stuff, you'll find it. And I'll put the link for it in case you decide, hey, I do want one of those. You don't want to have to go plow through a bunch of videos. I'll put the link in this video to show you where to find that, if I can remember when I'm editing. I mess up sometimes, guys. So let me continue on what I'm doing. I'll be back with you and we'll get this board tested. Okay, I had to run one bodge wire underneath, screwed up one trace, didn't run it. Actually, had to remove the heater SSR off the board, and on the positive for the trigger pin, I had to take a razor blade and cut it loose. It was to the ground planes. So it wasn't connected to anything but the ground plane. So I isolated it by cutting a square around it with a razor blade knife, and then I ran one bodge jumper wire from it over to one of the pins of the controller, and that took care of that problem. So not too horrible for the first prototype. Anyway, got everything working, been testing everything, pulled out the my little $6 incredible little $6 AliExpress data analyzer. This thing works so good, it's unbelievable. Anyway, I've tried the serial connection for communicating with the screen. That's working fine. The power on and off for the screen's working fine. The microcontroller can turn it on and off as needed. Power for the heater is working great. It's cooking this thing up pretty good. Kind of putting it through the paces. Temperature sensor's working. If I get her down on here where she gets some heat on her, she'll shut that thing off. And so it's all working good. My low voltage converter's working okay. Noticing a few lines on the display here. Don't know if maybe because this is a little too noisy. Could be. Might need to bodge in a little capacitance there to kind of smooth this power out. Could be I'm running from the power supply too. So we'll have to see. Seems to be working good. I can see on the data analyzer, I can see the current measurement from the current chip being transmitted to the screen to show. It's sending, what the current draw is to be able to show, and temperature and all that. I see that coming across. I also hooked up to the SPI to go out to the analog to digital converter. No, I'm sorry, digital to analog converter. Get it backwards all the time. The digital analog converter, tell it how many volts we want out. I can see that data moving just fine. I've got some test code in there, if you remember, that just kind of doubled through the numbers. I see that increasing each step, so I know that's working well. This board is pretty much on the go. Been nice if I didn't miss that one trace, but hey, when you're designing a board for the first time, kind of hard to get everything perfect. You try and you look over and you look over and you look over, but you still make mistakes from time to time. The next setup is what I'm going to do now is, and I'll let you see what I'm doing. I've got to come up with something to hold this temperature sensor and our current fuses up against this case so it can sense the temperature and make the fuse blow if it gets too hot. I want to make up, I'm going to 3D print, I'm going to design and 3D print a holder for those two items and have them actually screw on the side. So I'll come back when I've got a little bit of the work done on the computer and show you what I'm doing. Okay, so here's what I've come up on CAD. I created a little block, two 3mm holes to screw it to the side of the oven. And I just chamfered the corners to make it a little nicer looking. But underneath, what you've got is two compartments. This is one for the temperature sensor, and this is the thermal fuse. And what I'm going to do is put a small piece of foam, of that black foam we're using to insulate everything, here and in here. And then when you place the part in here and screw it, the foam will allow the device to contact the side and compress into the foam and keep good contact so that we have good temperatures. And because this will be a kind of a closed area here, it'll help make sure that with that insulation, it'll make sure that the thermal fuse heats up quick and gets up to temperature, and the sensor too. And that way, this thing will blow fairly quickly when it gets up to 65°C, and this will get a good temperature reading. So pretty simple, nothing complicated, but I think this will work just fine for our use. So all I've got to do now is 3D print it, and we'll see how it turns out. So give me a little bit to 3D print it. We'll check. All right. Well, I've got our 3D piece made. Let me pull the screws out here. As you can see, I've got it drilled. It'll bolt right on the side of the oven. I've got the oven pulled out. Here's our heating pad. And I've got our little sensor. If you look in here, I don't know how well you're going to be able to see it. I've put foam in here. And so let me show you what that does for me. Here's my little thermal fuse. And by the way, if you ever try to solder wires to a thermal fuse, you got to remember that you're going to heat it up and pop it. I had to submerge the body into water and solder each end to keep from overheating it, because it's only 65°C, which, you know, you're soldering it quite a bit above that. So it's a little tricky, but I got it. So you can see this fits right in there, and there's foam. And if you can tell, when I push down, it kind of springs back out. So when I push here, I can feel it pushing back on my finger. That's going to hold it in contact with the aluminum of the case and make sure I get a good temperature, and insulate it, which will help heat it up, you know, quicker to the temp of the case. Got the same thing here in a very small little setup. Oh, let me find my temperature sensor. Here he is. Here's my temperature sensor. He does the same thing. He goes in, and if you notice, he's got foam and he's springy. And so what happens here is we simply put this in. And I'm going to turn it around because I've got it backwards. Let me flip it up this way. We get our our thermal fuse in. We put our heat sensor in with the flat side out, and then we bring these two rascals onto the case like this, and then it just bolts on. And now we've got a good way to hold it to make sure it's in good contact, and yeah, that's going to work good for us. So that's it. I mean, I'm pretty happy with how things are going. I'll go ahead and screw that down, but everything else on the board is checked out. I'm going to say that our controller board is functional and working. I'm happy. And so that's going to end this video. Hey, thanks for hanging in this mess as I try to get this all working. Next step is I'm going to have to get to work on the design of the board for the that goes in the oven, the actual, you know, digital to analog control board and reference. So that's going to be a big job. There'll probably be some videos between then. Probably going to be doing some radio work next few videos, and that'll give me time to get some things figured out on that board, and then we'll try to get that board designed and coming so we can keep working and get this thing finished up. So hey, thanks for hanging in here. Do me a favor, hit like if you like the video. I really need likes, and subscribe if you haven't. But most of all, I hope to see you in the next video.